When creating mathematical animations in Blender, one finds themselves needing to visualize vectors quite often. This is a quick guide on how you may go about creating usable, flexible vector objects with geometry nodes. Let's begin with an origin point, as well as an endpoint. These vectors can be replaced in the future by the locations of objects or something we'd like to track. The target vector from its origin point to its endpoint can be easily calculated with a vector subtract node. We'll define the body of the vector, that is, the line segment, with a curve. The start of the curve will be defined by the origin point. The direction will be defined by the target vector, but normalized. The length of the target vector can be extracted with a vector length node. Let's convert this line to a mesh and use a circle as the vector's profile. Here, we can adjust the thickness of the vector body. Plug the output of the curve to mesh node into the group output, and we have a visualized vector. This is a good start, but we also want an arrow at the end of the vector to indicate direction. We'll add a cone primitive node and join that geometry with the line to make both visible. The parameters of the cone can be adjusted to customize the head of the vector. Our first objective is to have the cone point in the direction of the vector. Let's insert a transform node in between. We'll use an align Euler to vector node to calculate the correct rotation. This node will take an input vector and return a rotation transform for the object we'd like to align to the vector. Let's insert the normalized target vector into the node and plug the output into the rotation transform. Make sure the axis is set to the z-axis as to be aligned along the height of the cone. Let's then use the sum of the origin and the endpoint vectors to calculate the correct translation to move the arrowhead to the tip of the vector. It seems the vector now overshoots its target endpoint. We want the tip of the arrow, not the base of the arrow, to be at the endpoint. Let's remedy this by defining the height of the arrow with a value node. We'll subtract this height value from the length of the vector body. Finally, to position the arrow correctly, we'll multiply the target vector normal vector by this new vector body length and use that value in calculating the translation of the cone, instead of the endpoint vector. This has the added benefit of being able to adjust the length of the arrowhead without distorting the overall vector length. And that's all there is to it. Customize this how you'd like, and subscribe if this was useful to you in any way and you'd like to see more content like this. As always, a high resolution image of the final node tree will be linked in the description. Peace.